Good morning and welcome to today's webinar, Transforming IT Operations to be a Strategic Ally to the Business with IBM Watson AIOps and Turbonomic. This webinar is brought to you by Express Computer in partnership with IBM. I'm Sudipta Dev, Senior Associate Editor with Express Computer. Meeting SLAs for hybrid applications can be a complex problem. To effectively reach availability goals and performance targets, one must have intelligent insights to mitigate risks and reduce costs. IBM's hybrid cloud solution comprised of Watson AIOps and Instana's observability platform provides AI-driven automation and insights for incident remediation, problem determination, and application impact avoidance. The powerful combination of IBM's AIOps solution, along with the award-winning application resource management technology of Turbonomic, can transform your IT operations to a strategic partner in today's ever-changing business environment. Sharing with us the expert knowledge are our speakers for the day: Richard Wilkins, Distinguished Engineer, AIOps Elite Team, IBM Cloud and Cognitive Software, IBM Asia Pacific. He has been with IBM for 30 years and was appointed as an IBM Distinguished Engineer during 2015 in recognition of his extensive track record in leading technical challenging IT service management projects. He will be giving a presentation on Watson AIOps. Our next speaker, Mr. Greg Beal, is Regional Director of Asia Pacific for Turbonomic. Greg specializes in bringing innovative and disruptive technologies such as Turbonomic to the market. Today, he will be talking about assuring application performance on any cloud with AIOps. Our third speaker, Sergey Omilaenko, Manager Pre-Sales Systems Engineering and Solution Delivery, APAC, Turbonomic, has more than 2 decades of experience in the IT industry, including more than 3 years in Turbonomic, in various customer-facing technical and operational roles. He will be giving a demo, Turbonomics. Before I hand over to them, I'll go over the webinar information. This is an audio and video webinar being broadcasted live. We will have polls in between the webinar. I request you all to participate in the same. We will have a round of Q&A at the end of the webinar. However, you can send in your questions anytime during the webinar using the questions box. If you face any technical issues, please try to refresh your browser or else reach out to our team using the same questions text box. If you have any questions unanswered, we will connect with you over email to answer the same. We also have a survey form opening at the end of the webinar. The form will open in your browser, and we would love to hear your feedback. Before I hand over to Richard, we have a poll. Can we see the poll questions, please? Okay, so here is the poll. How often do you suffer slow application performance? The 4 options are there: hourly, daily, weekly, and of course, any other option. I'll read out the question again. How often do you suffer slow application performance? Please select one of the options. And Richard can then, give his insights on this. We still have a few seconds left. So these are the results. So I invite Richard to take the second session forward. Richard, the floor is yours, and what are your insights on these results?
Awesome. So thank you very much. Let me just go and share my screen. Okay. All right. So thank you for the introduction. That was really quite awesome. Yes. As introduction, I'm Richard Wilkins. I am a distinguished engineer at IBM. And what I'll do today is I'll spend a little bit of time positioning and talking about Watson's AIOps, and going through some of the rationale, why we do what we do, and then how we actually achieve some of the things, and then some of the benefits. Okay, so I want to start a little bit by setting the stage. I'm going to refer to Gartner a couple of times in my presentation, just because Gartner have been fairly active in the AI ops and analyzing them and taking a look at some of the market trends. And they've gone through and actually looked at what has happened over COVID-19. They've looked at
Sorry
some
to
of the
interrupt.
reactions.
Mr. Richard, if you could put your presentation on slideshow mode.
Okay, it should be on slideshow mode. Am I presenting the wrong screen?
Swap screens, Richard. Swap displays.
We are seeing speaker notes.
We're seeing speaker notes.
Let's do that. Is that better?
Yes.
Yes.
Okay.
There you go.
Sorry, technically challenged. Happens to all of us. Sorry. Okay. Thanks for the correction. All right. So yes, Gartner went through and had a look at industry trends, identified some things that happened because of COVID-19. We really had to change our strategy in the way that we approach things because of COVID. And today, you know, going forward, tenfold the number of businesses will be looking to rely on an AI ops platform to run their business. I mean, it's necessary, it's required, and it's to help with the scaling of things. But what it has meant is that it has become one of the top 2 initiatives that customers are executing on this year and next year because of the drive, because of the need for this. AI ops as an initiative in most companies has risen to the top. And I'd like to discuss what that means and some of the impact and outcome of that. Okay. And I'd like to look at that in terms of the operations teams. AI ops, as inferred by the name, is targeted at the operations teams and really helps them with what we're calling digital transformation. The development side of the house went through this transformation probably about 18 months ago. They went through and they had a look at different aspects of how do they do digital transformation. They adopt agile practices and principles. They built a CI/CD pipeline. They started exploiting the cloud and moving applications towards the cloud. But the operations teams couldn't pivot and couldn't change as fast as the development teams could because they were running. They were, you know, an active part of the operation, that they had processes and technologies that they couldn't change as fast. So they were kind of a little bit slower in the adoption. But what we're doing here with AI ops is we're accelerating that. We're catching up. Operations are now starting to adopt some of these newer practices and principles. And I like this picture we put up here because it really shows an operations teams which has moved to almost lights out. If you look, there's 1 or 2 guys in the top left, you know, but most of them have sort of, you know, as I say, gone to the beach. They've gone home. We're running this as a lights out operation, and we're using modern principles and tools and processes as well. Okay, so this is a transformation. It's not something that will happen overnight. And so what I will do is I'll put up this bit of a diagram which kind of shows the evolution that an operations teams tend to have to go through when they're moving from the traditional sysadmin approach. You know, it's focused on availability, and really that's where they're what they're focused on. And if you do focus on that, once you have an availability outage, it's too late. You know, things have already gone wrong. You started to affect customers, and you know that the term slow is the new down. If you've lost availability, then you've gone past slow, and your customers are having impact. And this is why I said before earlier on, you know, how many times do you have a slowdown? In the results came, you know, typically weekly. A couple of them came and you said daily and daily, but most people seem to have a weekly slowdown. And what we want to do is we want to shift the focus so that we can catch those slowdowns and really observe what's happening, catch them, and then put something in place which prevents them from causing an outage, prevents them from affecting the availability, right? And Serge and Greg will talk about some of those components in them shortly. But really what we're talking about here is the ability for operations to transform themselves from being traditional sysadmins into a modern SRE, cloud native, exploiting the cloud type environment. And the use of AI ops and the particular tooling that we'll talk about today definitely helps promote and speed up that transformation. As we said, you know, tenfold the number of customers that are focused on it, and it's some of the top initiatives. for that. I'm going to put up a bit of a slide, why IBM, and this is kind of me beating my chest saying, yes, IBM is really cool. We are the leaders. There is no doubt here that IBM is the #1 AI company in the world. We have been for a long time. This is, again, a Gartner study. It shows IBM in the Magic Quadrant as a clear leader for AI and automation. I mean, the background to this is really IBM research. And in the Watson's Cloud Pack, which we'll talk about shortly, there's 120 patents alone just in analytics, which shows a clear leadership in how we perform and do our analytics. There's no other company in the world that can do what we do in terms of this. So again, go and take a look at that. And as I said, I have another Gartner study. This one, and the reason I put this up is I'd like to talk about the definition. What does AI ops mean in terms of the impact? And what is the definition of it? And everyone has a slightly different view of it. Gartner set the scene again probably 2 years ago with their definition of it. I encourage you to go out and read the white paper, actually. It talks about the benefits of doing AI ops, what you can expect from it, and the reasons why. Why should you do AI ops? Gartner, I do like them, but they stopped short. They didn't say how. There was no prescriptive step of how you actually do that. So that's what Greg, Serge, and I are going to do today, is we're going to talk about the prescriptive how. How is it that we actually implement some of these things? Okay, so then I switch on to the bits that I'm going to talk about, is the IBM point of view. It is slightly different from the Gartner point of view. We're a little bit more prescriptive. So they say, yes, you should do it. What I'm talking about here is we're taking AI for IT operations, which is a very specific set of AI models, and we are infusing them into operational processes like incident, problem, and change. And we'll show you some of this in action. Right, so we're very prescriptive about some of the things that we do, and we have a reference architecture. We have a journey that we go along, and there will be certain levels of maturity that you will go through as you follow this journey. It's not overnight. You can't walk in there and say it's a big bang approach. You must take this with a prescriptive, holistic approach, and look at the components that are going to be meaningful to you, and then adopt those first. English, we say, take the low-hanging fruit, right, to give you the best success and the best returns on it, and then you can work through the other components of it to bring some real value and drive it into the business. Okay, so I won't spend too much time on the reference architecture. It is available and published. If anyone wants to talk to me afterwards, please do so, and we can talk about it. But what we do, how do we do this? And I really want to bring this in context to talk about some of the products that we're going to put together today. And we've got Turbonomics and Watson's AI Ops to show you. We also have observability component, which is done through Astana. We have the analytics component, which is done through a combination of Turbonomics and Astana. We have actions, which Turbonomics will show you. And then we have the predictive insights, which is the Watson's AI Ops. Now, as I said, it is a journey, and you don't have to start from 1 and go through to 4. You can start in any order, look at what's relevant for you, look at the particular use cases that you might want to implement, and then go through and implement them. And again, Serge later on today will actually show you some of these use cases for it. Okay. So what is it that we're going to do in terms of Watson's AI Ops? I know you've all been waiting to hear what it is, what is under the covers, what are some of the things that we do. So I'll give you a real quick overview and a summary. Basically, we take data from a particular data source, and we don't really mind where that data comes from, and we categorize it into 4 basic buckets: unstructured data, structured data, events, and topology. Okay. And then what we do is we bring them into the Watson's AI Ops platform or subsystems, and we have specific analytics that act on each one of those data types. I put this slide up kind of to say, hey, yep, we have a large number of logos and things which we can bring the data from, but I don't really want to concentrate on that. What I really want to do is say, it's data, and I want to treat it as data, and I want to remove the domain boundaries from it. I want to remove the fact that, you know, this is a database metric and this is an operating system metric. I want it to be a metric and I want to analyze it as such. The same with logs and tickets and topology. Okay, so we treat this as a particular data source. We bring it into a fit for purpose analytics component. So the AI manager that we've got here is industry leading analytics around processing and managing unstructured data. Event manager, the same thing. It has industry leading analytics around handling events. Same with metrics and topology. So those are targeted specifically at the data type that we are analyzing and producing. Then we bring all of that, it's not actually shown on the diagram here, but we bring across another set of analytics across all of these data types to bring them all in context. So we say, hey, what is happening across all of our logs, our events, our metrics, topology changes? Do I have one problem? Do I have 5 little problems? And I understand that in context. And then I raise that out into the operators, into what we call a story here, into a ChatOps experience. So that's what Watson's AIOps is doing. It's taking industry-leading AI, it's applying it to a particular data type, and then bringing it in context and displaying it for the operations team so they can then go and take action and fix problems before they go. So that's kind of in a nutshell what we do in Watson's AIOps. What I'm going to do now is I'm going to hand over to Greg, who's going to talk a little bit about Turbonomics and talk what they do in terms of analyzing some of the workloads and workload placements in some of the areas. But again, I think I'm stealing your thunder, Greg. So why don't I hand over to you? And I think we may have a poll question as well for you as well.
Thank you so much, Richard, for the very informative presentation. And before Greg starts his presentation, we have the poll question. I will read out the question for you and also the options. So one of the primary reasons IT exists today is to assure performance of applications. Which of the following reflects how your organization does today? The first option is we have a significant number of people monitoring for alerts and alarms. And hopefully when a critical service is impacted, our people are able to troubleshoot or restore service before the complaints become too loud. The second option, we do the above and also use hardware over provisioning to attempt to cater for the peaks in demand. In the cloud, this is proving to be very expensive and we pay for the resource we over allocate regardless of whether we use them or not. The third option is we use an AI solution to ensure the applications are continually resourced. Our people control the policies and we trust the AI engine to ensure our apps are continually resourced at the lowest cost while maintaining compliance with our policies. So audience, please select one of these options and we will have the results soon before Greg starts his presentation. Question again, one of the primary reasons IT exists today is to assure performance of applications. And you have to select one of these options. We have a few seconds left. So please select. So, okay, can we have the results, please? Right. So the results are here. And Greg, what do you think about it?
I am not surprised. Yeah, it's very, very interesting. Very interesting. And yep, I think that's good. I think it's a good segue into our discussion today. Let me just try and share here and we can, am I sharing the right window? Yes, I think I am. Okay, yes. Good morning, everyone, and thank you, Richard. Very insightful information that you shared there. We do have a live demo coming up following me from Sergey, so I do want to I'll skip through a bit of this because Serge will bring to life a lot of what Richard and I are here to talk about today. So the title of my presentation, as you can see, is Assuring Application Performance on Any Cloud with AI Ops using Turbonomic. So let's slide forward if we can. Yep. So I'm sure everybody on the call today is very, very aware of the fact that it's getting more and more complex to assure performance of applications today, mainly because of the complexity of modern applications. And what we see here is, is the fact that there is 100x more components that make up an application stack today, with 5x more stakeholders, with a release cadence of 100x what it used to be. It used to be annual, then it went to monthly, daily, and now there can be multiple releases a day. And there is more management tools than there ever were. So with that in mind, why is it so complex? Well, before we get to that, we're going to talk about the size of the prize. And this is the results of a survey done by the App Attention Index in 2019 and Akamai. And you can see here that the penalty for poor application experience is high. 49% of these users switch suppliers due to a poor digital experience. 50% are willing to pay more for a digital experience better than the competitors. And 100 milliseconds delay in load time equals a 7% drop in conversion. We're also facing, we have a particularly strong sector with banks, because obviously of the critical nature of their applications. And we have we have 35 plus banks globally that use Turbonomic to assure performance. What one of our big customers told us not 3 weeks ago was their number one branch in terms of transactions these days is their mobile app. And 3 years ago, it wasn't on the radar in terms of a top 10. So it further reinforces that the applications are more important than they've ever been. They're more complex to manage than they've ever been. And yet, how have we fundamentally changed how we manage them? And if we have a look at the reason things are as they are, obviously that you've got an application stack. Now, the applications obviously sit at the top, and this doesn't matter whether it's on-premise, hybrid cloud, public cloud, virtualized, containers, microservices. The common thing is applications have to draw their resources from somewhere. And it doesn't matter what that underlying stack is, those resources, if they are required, if an application requires memory, that memory is not available at the time it requires it, we obviously get a performance issue, yeah? But if you have a look at obviously the stack as it sits today, for all of the great things virtualization did and all of the very, very advanced descriptions of virtualization, it's a tool that allowed us to share underlying resources. The problem with that is it works fine until there's resource contention anywhere in the stack. And resource contention is the bane of an application's life, because that is where that symptom actually is displayed. But if you look at today, so yes, we all agree that the application stack and the infrastructure stack, the underlying stack, is complex. If we look at how it's managed today, it's managed in silos with people that have expertise in each of these silos, often with tools that give them visibility into each of these silos. But the stack itself is not connected. And therefore, what you have is people monitoring for alerts and alarms, which is reactive in nature, and then humans trying to analyze a stack that is 100 times more complex than it was 5 years ago. And therefore, it is inconsistent at best, problematic at worst. And when the resources aren't available to the applications, best case, critical applications are going to see this. Too often, what you have is this scenario where an application is impacted, conversion rate is dropping. This is the business war room on the left. And somebody calls down and says, what is going on? And typically, as we all know, we've all, perhaps done these jobs ourselves in past lives, or managing the people that are doing them today. Many times what happens is, what can IT tell you when this business problem happens? IT can tell you that what the problem is not. Long time before anybody can say what the problem is and how it can be remediated. And why? Because with just monitoring, you've got people looking at screens like this. Now, this is fine. Visibility is fine. Visibility is fine versus no visibility. Yeah. But there's one problem with this. You've got people looking at screens like this, and you have seen, Richard had a beautiful graphic actually in his presentation of it looked like mission control at NASA. And we've all been through, we've all seen those. The problem is you've got multiple screens of people looking like this. This doesn't answer one question. Why did it happen? Or two questions. Why did it happen? And what do I do now? What do we do now? And too often this ends up in a war room situation with every layer of that stack coming in together. And what's the first thing that everybody presents? They present, it's not me. The storage guy says, it's not me. The application guy says, I don't care who it is. The application's slow. Virtualization guy says, it's not us. And it's left usually to the network guy who has to prove he's innocent before anybody else looks any further. We think that this is yesterday's technology. And as the applications become more and more complex, this is not going to cut it going forward. It's also not necessary if you're a Turbonomic customer. Because if you're using real-time AI to assure application performance, you're not looking, your people are not looking at things like this anymore. Alerts are replaced by analytics. And what does that mean? That means that you have, in our case, an AI system that algorithmically matches demand for application resource with supply continually in real time. We have 15 patents on this, okay? And what you get is an understanding from the top of the stack where the application sits, how it is connected all the way through the underlying fabric, regardless of whether it's private cloud, public cloud, or hybrid cloud. And what you see here are prescriptive actions that our analytic engine has produced that says, these are all the actions that have to be taken for the applications to be resourced according to their demand. No thresholds, no manual setup, no guessing, no bill shock, no waiting for something to break for humans to have to go investigating what to do. So an analogy I like to give is an aircraft one. This was okay when you're flying a single engine aircraft with digital instruments, okay? It's a lot, but there's a reason that didn't go forward to the A380 where they spent $1 billion on updating the avionics and had computers flying the aircraft. This is the avionics of today for application resource management. Now, why should you care? Well, if you're on this call today, it's probably because you've got a business that's got critical applications. You may have even invested in an application performance management product because you wanted to make sure that that application layer is healthy. But that application layer, you can have a perfectly written, perfectly architected application. If it doesn't get access to the resources, it's just like having a Ferrari that has no fuel. It does not work. We solve that problem. And how that manifests, and Serge is going to show you this, is you end up with a common perspective for the modern application hosting service, where you've got one data set that the operation folk and the app folk and the network folk and the storage folk can all see how their particular silos are impacting or resourcing the application. And it's all done via AI. So how do we describe Turbonomic? It's an AI engine that ensures the applications receive all of the resources they require continually in real time at the lowest cost whilst maintaining compliance with policies. It works across private, hybrid, and public cloud. It's agentless, agnostic, and application aware. Okay, note agentless. Now, it's not a monitoring tool. You've got enough monitoring. If we said to you today, can we sell you some more monitoring? You would probably say, I've got 5 already. I really don't need to pay for a 6th. In fact, we probably couldn't give it to you. Yeah. But what we're not talking about monitoring. We're talking about using analytics, AI, to assure application performance by keeping them resourced. So let's have a look at how this really plays out. If you have a look at a typical bank, and Serge is going to demo this live, but what you see here is we connect into each layer of the stack and we understand what the demand for the applications that we are seeing is, and we understand what supply is available. And then we match demand and supply to produce actionable recommendations. You can drill into particular apps. So in this case, if you said, okay, I'm a bank and I've got a BPay application, right? We can drill into that and see whether we have got resource contention anywhere in the underlying stack and how it is affecting the application. We can see whether we are violating any SLOs, any service level objectives, okay? And we can see whether spikes in response time correspond to spikes in demand or whether it's a resource contention issue. So if we drill through further, we are then able to provide prescriptive actions that you can automate, which is a really important point, for each layer in the stack to ensure that the applications are resourced. Note that this is very, very different than waiting for alarms, for something to break, for people to investigate, for war rooms to form, for people to say it's not me before anybody. That is what we call the break fix loop, and it's never ending. This is about using AI to prevent resource contention from impacting the application to start with. And what happens when this works properly is the applications continuously perform, resources are efficiently utilized, which means on-premise, we typically are able to double headroom. And in the cloud, we are able to predict what the cloud spend will be before workloads are migrated, and we're able to continuously optimize. We usually save somewhere between 30 and 40% of a customer's cloud spend whilst assuring performance, which is the key thing, simultaneously assuring performance. Because if I said to you that I can save 100% of your cloud cost, but I might break all of your critical applications, we're just not sure. I'm not sure that you're going to pay me for that solution. But if I say I make your apps run better and I save your money, you probably want to talk to us after this call. Policies are followed and they're still your policies. You don't hand over total control, okay? You have policies, you say, I don't care what you recommend, this app stays here because we know it works and it stays here and we don't care about the additional cost, no problem. The AI engine ignores that, moves to the next thing. And IT can go back to adding value to the business and doing things that humans can do that software can't do. But these first four things, software does better than humans do. And what's the size of the prize? Generally, we see that we've shown you a very conservative thing here. Generally, we see anywhere between 25 and 100% increase in density in an on-premise environment, whilst assuring performance. And in a cloud environment, as I said, somewhere between 30 and 50% is the saving whilst assuring performance. It's not all save, save, save. You can see here some of these applications actually require more resource. They need to be upsized from where they are now because they are not performing because they don't have enough resource. Others are over allocated. And what that means is you can think of it as the autopilot, real-time actionable decisions, and over time, historical time series analysis. Yeah. We have major customers with major critical applications. There's 3,000 of them now that use this.
And with that, I'd like to hand over to my colleague, Serge, who is going to give you a live demonstration of some of the things I've shown here. Thank you.
Greg, thank you. Appreciate that. Sorry, there was a small technical glitch here, but it appears to be all working fine. I think you should be able to see my screen now. Okay, so as you've just seen in the presentation, so this is live demo, and I'm going to demonstrate you the application resource management engine live. So what you see here on the left side is the supply chain, which stitches together everything, the entire stack. Basically, it comes from the top, from the business applications, going down to the containers, going down to virtual machines, hosts, storage, and so on and so forth. And obviously regions and zones if we connected to public cloud. So this is the actual application view. And we can drill down to any particular application. So for instance, we can actually go and actually check, well, this specific app. And for instance, Robot Shop is one of my favorite one. And right now, so you could see the supply chain gets redrawn and you could see specific, well, only components which actually rely, well, this particular business application relies on, they're only shown here in the supply chain. And most important part of it is, it's not just, you know, graphs and all of that. Most important part is pending actions, which you could see here. And these are specific actions which are for related for this particular app. So what do I need to do in order to assure performance of my Robot Shop? You can click on any of the actions and you could see there will be some storage actions for the storage devices. There will be some actions for virtual machine moves. There will be some actions for resizing of containers and so on. So and these actions will be, again, specific for this particular app. So if we go back to the main screen, this is my entire infrastructure. You could see the supply chain all of a sudden is actually quite complex. And again, most important part of it is not alerts and alarms, but actions. What do I need to do in order to keep my environment in the optimal state? So we can go through and explore some of these actions. So for applications, for example, I might just need to resize heap for a particular application component because it's been oversized. And you can click on the details and it will tell you why exactly that needs to be resized. You can drill down to the on-prem environment specifically, and you can see actions for virtual machines which need to be moved from one host to another. You could see actions which perhaps some VMs need to be resized because it's running, low on the particular. This particular one is basically hitting the 100% memory utilization, and if it gets resized, obviously I just add another gig of memory. All of a sudden, you could see this is potential. That line shows you what would happen, or emulation, what will happen where the utilization going to go if I take this action. So the idea here is, as you've seen, we're not just by displaying all these alerts and alarms or performance graphs. You could see, you can view them if you wish, but the idea here is we show actions, what needs to happen in order to bring the environment in the optimal state. And the optimal state is when all the applications are resourced based on their demands, and those demands change all the time, while the infrastructure underneath is utilized in the best possible way. So I just drilled down to one of the applications. We can go back there again. I can, for example, select on-prem environment, and you will see that my supply chain got redrawn, and it's got only components which I host on-premise. Actions again, only showing actions for the on-prem environment. Now I've got clusters, host utilizations, and all other bits and pieces, and you can actually click. All of this is clickable. I can see the headroom for each of the clusters and so on. In a similar manner, I can go to the public cloud part. And again, supply chain gets redrawn. It shows me components which are applicable for only public cloud components. And then you could see this pricing table here. Very simple. We show two columns, blue and green. Blue, it's what I'm currently paying for my cloud infrastructure. For 232 workloads, I've got across Azure and AWS. I have some of them, 7, are actually undersized. They are with performance risks. 44 have been oversized and they can be downsized. 2 are out of compliance. So perhaps they sit in their own region, or if they're part of the consistency set, and one has been resized, one is not, well, that's compliance issue, and we highlight that. But the idea here is, currently I'm paying $19,000 for my environment. If I take all the actions which are listed here, I will be paying actually almost 30% less and assuring application performance at the same time. So, and if we look at some of these actions, they're actually quite fascinating, and we can drill down to Azure, AWS, and GCP here. But for instance, if we take, if we go on the volumes, and we even show which actions can be taken non-disruptively. So you could see this checkbox. So for instance, this particular volume can be executed at any point of time. Any action can be executed at any point of time. So I can check the box and execute it here, or I can set up a policy to have this executed automatically. Any of these actions can be automated in real time or scheduled if you can't execute it during business hours, for instance, or execute from here. But if we look at the details for this particular action, this is actually quite interesting. So you could see this is a volume in AWS, and it's attached to one particular virtual machine, and it actually sits on the standard disk. And what we're saying is we need to move it from standard to GP3, high performance. And as you know, all cloud providers, AWS, Azure, they refresh their offering all the time, and because we're simply connected to their to the portal via API, we can actually refresh all the offerings every 24 hours. But if we're going back to this particular volume here, it's hitting 100% all the time. It sits on slow 160 IOPS disk. And what we're saying is, if we move it to this GP3, it will actually receive 3,000 IOPS. And further to that, it will result, well, a part of the fact that performance will be assured, so it will be only utilized at like 2.4% versus 100% right now. It will result in savings of $55 a month. So right now, the storage cost will be, it will go down from what we're paying 7.6 cents an hour to 0.01 cent an hour. This action can be taken and executed immediately. Downtime is not required and can be manually reverted. So if you ever decide to go back to the slow and painful disk, you can even revert it back. And for all the actions here, we actually display what can be, if it's reversible or not, what the cost impact is, and if it's non-disruptive or not. And we can go and look at virtual machines in a similar manner. You know, in the public cloud, we're going from one template to another, and we actually show if we can cover this with RI and so on and so forth. Now, I don't know how many of you are aware, but for instance, if we take AWS alone, there are approximately 1.7 million combinations of compute and storage alone. So it means if you have one workload in public cloud, you have 1.7 million options to choose from between compute and storage at any given point of time. And 50% of those options change every 6 months. So what I'm trying to say here, this is completely beyond human scale, trying to keep up with application demands while trying to save cost at the same time. But saving cost, it's not the point here. So yes, it will automatically save the cost for you because we'll choose the template which is the best suited for the application demand at any given point of time. And further to that, we can assess what resolved instances currently available in the account, what virtual machines can be moved in and out of those resolved instances, what other resolved instances you can purchase, billing and so on and so forth. So this is for the all public cloud. On-prem, in a similar manner, maybe the cost for on-prem is not as obvious, simply because on-prem infrastructure already in place and you're not paying per minute or per second for its usage. But the idea is exactly the same. So we need to ensure that application demands are met while infrastructure is used in the most efficient manner. So, and this is basically the idea of this platform. So, and again, going back to the applications, and if we drill down to any particular one, so for instance, we'll look at a couple of others, mobile banking transfers app, for instance. This is on-prem app. It consists of 4 virtual machines, and I can actually click through on any, well, this is like my customized dashboard for this particular app. And I can see actions, even though the infrastructure is shared, I can see actions specific to my application. So, and all these views are customizable. So this particular view could be given to an application team, and they can even run or execute their own actions. Apart of the fact, or they can automate these actions. So the permissions and all these policies can be tweaked in a way that you could actually, well, it's basically infinite number of different options available here in terms of what can be done. But the idea is anyone can assure application performance here, from IT managers, which may see the entire infrastructure here and all these actions, which can be automated, to specific application owner, which can go in and say, this is my app, and I would like to look just after my app, even though the infrastructure could be shared, they could be only given permissions to execute their own actions in relation to their particular app. It's just fully flexible. Now, very briefly, the other bit which I would like to cover is simply because it's a single pane of glass for the applications, for on-prem, and for the cloud. We collect statistics during the operations, just simply because we collect the data. As Richard mentioned in the presentation and Greg mentioned in the presentation, we collect the data and we make decisions what needs to happen in order to assure application performance. So you could also, the part of this product is also a planning function. So you could, for example, run a plan. What if I were to migrate some workloads to the cloud? So you can just pick a number of workloads. For example, I just say I'd like to take this cluster and I would like to send it to Azure, that particular account. I can pick a region. For example, this region. I can pick what licenses I would like to use, bring my own. I can select resolved instance settings, and after a few minutes, we're not going to wait, but after a few minutes, it will come up with the result. And we'll tell you what will happen. And I actually can show you one of the previously run plans, for example, this one. What would happen if I were to migrate these 200 virtual machines to the cloud? Well, in this particular case, that was Azure plan. Again, there are two columns, lift and shift and optimized. Lift and shift means I just picked all these VMs and emulated what if I migrate them to the cloud, what it will cost me. And green column indicates if I size them based on their demands, what the cost would be. And we display all the what templates you can use for the blue and the green plan, what volumes you can use, and what resolved instances you can use. And beauty is you can actually upload this template directly in this instance into Azure portal and use that, well, as a spreadsheet, as a CSV, to actually migrate these virtual machines, should you decide to migrate. But you know the cost up front, what it is on the blue plan, on the green plan, and with and without resolved instances. So with that, I just stop and give everybody an opportunity to ask questions. So thank you so much.
Thank you, Sergey. And thank you, Richard and Greg. Also, you have shared a lot of valuable information with the audience. I now open the floor to questions. I request everyone to use the questions text box to send in their questions, and I will take them one by one till time permits. We have the first question, and maybe Greg, you can take it up. We have lots of monitoring tools already. What would you say IBM ARM would provide us that we would not already be getting from our existing tools?
Okay, thank you for the question. The answer is simple. The ability to assure performance of the critical applications. And by assure performance, I mean ensure that resource contention is eliminated before an application is impacted. If you have monitoring tools, lots of them today, as lots of customers do, you have lots of alerts and alarms and people investigating alerts and alarms. Something is already broken or response time impacted before that happens. And if we look at what the results of the survey was right at the very start, yeah, there's nearly 40% of customers that are sitting there with lots of people monitoring alerts and alarms, waiting for something to break so people can go and fix it. This is a fundamental change. This is having software having software ensure the applications are resourced according to their demand before the business or that application is impacted. Thank you.
Thank you so much, Greg. The next question is, which are some of the top use cases for AIOps in enterprise IT operations? Richard, maybe you'd like to take that one.
Yep, let me take a crack at that one. And again, probably incident avoidance, very similar to Greg's application performance one. What we're trying to do here is identify an issue, maybe not a performance, but definitely within the application, and look at how do we keep the application running. So we're applying analytics into, as I said, described before, into 4 different types of data: events, metrics, logs, topology, and events, to look at how do I predict, or how do I understand how the application is performing today, and what are some of the things that I need to do to keep it performing. And if it does start to move away from its baseline or stop performing the way that I expect it to be performing, what are those corrective actions that we need to be able to put in it? But to answer the question directly, the primary use case for AIOps is incident avoidance, and trying to detect and avoid an issue before it happens.
Thank you, Richard. The next question is, can this be integrated with TSOM to generate real-time incidents, though it is proactive and self-healed? Richard, the gentleman would like to.
Yeah, the answer is yes. What we do is we take a baseline, we understand the behavioral performance, and so the action of taking a baseline is we observe over a certain time period or take historical. Right? But then yes, we feed in real time the events, metrics, and all the data types in real time from particular data sources, TSOM being one of them, and we can identify a behavioral pattern change in real time. So yes, we take a live feed from all of these and do it in real time. Yeah.
Thank you. And will the same product version serve different industries or different types of businesses or technical functions, or are there separate versions for different industries?
So no, the use cases that we have are usually apply irrelevant of the industry. And I kind of touched on that a little bit, where I took away some of the big names of where we get the data from and just treat it as data. I want to take away those domain boundaries. I want to take away that industry specific things, and I want to look at it at an application that's performing. So yeah, I'm saying typically there are some exceptions, because different industries will have a different focus on different areas of performance. But typically we find that AIOps is not industry specific.
Yes, thank you. And can this integration be done with Kafka? Is it achievable?
Yes, yes, absolutely. We integrate with a large number of open source tools, Kafka, Elasticsearch. All of these are standard out of the box integration types that we go and use and collect data from. One thing I will say, and maybe I didn't make this clear, is we don't actually store the data. We don't capture the data and store it. We still rely on the data sources, right? We just apply the analytics over the data. So we don't become another big massive data store and trying to store the data in multiple places. We utilize your existing data set and apply analytics to it.
Thank you, Richard. And we will take the last question now. So what are the different options, Turbonomics, available for customers?
I'm happy to answer it. I'm not quite sure I understand the question, moderator. Is it? Yeah, I'm not quite sure. I'll answer what it may be. So, Turbonomic can be deployed on premise or in public cloud as an OVA, a virtual appliance. There is a SaaS version that is available, but only available in the US right now. That will come in Asia Pac, maybe in a quarter or two. But customers have the ability to run it on premise as a self-contained appliance. It doesn't even have to be connected to the internet. So that's why so many banks run it, because it is inherently secure and sits within their own security policies inside their own data centers. If that's not the question, could the person that asked that question ask it a little more specifically, and we're happy to answer.
Yes. And somebody else is asking, how does it improve efficiency on connectivity? Is there an answer to it?
Okay, I can take that. So in terms of, if we're talking about network connectivity, we will generate actions for workloads to perhaps avoid high latent links. Simple as that. So we will generate actions basically just to help to overcome that problem rather than trying to troubleshoot it.
Right.
Thank you so much. And that's all the time we have for today. I thank our speakers for sharing such interesting and useful information on how AI can optimize application performance, build business resiliency, and help increase your ROI. To know more, you can contact the IBM and Turbonomics team. You can see the contact details on the screen. And thank you, audience, for your interest and time. There is a survey form at the end of the webinar. It'll appear on your browser. Please do fill it in. And thanks again, Sergey, Richard, Greg, for all the information that you have shared. There's a lot of valuable information and a great takeaway for the audience. And audience, thanks for your interest and time, and have a great day.
It is our pleasure. Thank you to everyone that attended.
Everybody. Bye-bye.
Thank you.
Thank you.
Bye-bye.